On problem number one, they give you this piecewise defined function. For less than zero, it's y equals -1. So step one here, step one would be to consider the function y equals -1, and that's for all x is less than or equal to 0. So let's see which one has y equals -1. Well, this is y equals +1. This one's y equals -1. I like that one. Y equals -1. This one's y equals negative. Oh, wait. Is that a -2? Oh, it's on -2. They're trying to trick us. Oh, my gosh. -2 on this one as well. See how it's counting by twos there? And then this is the one that's y equals -1. So there's really only one choice. You just have to focus on this first part of the piecewise defined function, and it's got to be answer D down there. Okay. But the other ones, maybe it's important for us just to look at it real quick. What does the function 2x look like? Okay, so step two, and I know you might be tuning me out now. Hey, I know the answer is D down here, right? But let's just focus on y equals 2x for a second. And it's only between 0 and 3. So notice between 0 and 3, here's where 3 would be, right? It's got the line y equals 2x. See, the slope is 2. We're going up. Let's see here, up 2 over 1, up 2 over 1. Yep, definitely a slope of 2. And then they got an open circle right here, right? Because see how it's just greater than 0, and then it's less than or equal to 3, so it goes all the way over here to a solid dot. And then our last function, step 3 here, would be to graph y equals 6. Okay, so we were going between 0. Oh, shoot, that's not equal to 0 and less than or equal to 3. And then we were going for x greater than 3. So y equals 6. Yes, y equals 6 would be a horizontal line right there. That's y equals 6. So definitely this function over here. Now, what I'd like to try to do is get that on the left side of the screen and our drop-down menus on the right side of the screen. So we're looking at question number one here. It says the function is defined for all values of x. So the domain is all real numbers, right? So when we look at the graph over here, oh geez, let's see if I can find the graph. It's defined everywhere, all x's going all the way out to the left, all the way out to the right. So that's why we're choosing all real numbers. The range is -1 and all real numbers. Okay, so it goes from like here's -1 right down here. And then all real numbers that are greater than, so we're looking for y values that are greater than 0, right? So greater than 0. And then it says, and, oh, wait, it's going to go greater than 0, but less than or equal to 6, right? Because look, the y value is 6. It never gets above 6. So we want less than or equal to 6, which is also represented as f of x such that f of x equals -1, or between 0 and 6 right there. We want all the y values. That's what f of x stands for, all the y values that are between 0 and up to 6. The y-intercept, does it have a y-intercept? Yes, it does. See that solid dot right there at -1? So the y-intercept equals -1, and there is no x-intercept. Really? No x-intercept? Oh, yeah, there's an open circle right there at the origin, so no x-intercept. The function is it increasing from 0 to 3? Yeah, it's going up between 0 and 3, so it's increasing. Man, I hope I'm making this clear. That's how we deal with piecewise defined functions. The function's defined over different pieces of the domain differently, okay? That's why it's called piecewise defined. All right, thanks for watching video 2.